This is the introduction to section 7.2. This is part 2 of this section in 7.2. We talked about in part 1 being able to determine whether two shapes are similar, and we talked about similarities and everything that goes with it. Now we're going to start diving into some perimeter action. Now, in terms of perimeters, a couple things that we need to figure out first. And first thing we're going to write down here is, what is the definition of perimeter? What is a perimeter? If I find the perimeter of something, okay, what is the perimeter? Well, the perimeter is the distance around the shape, okay? In other words, to find the perimeter, we're taking and we're adding all the sides up together, okay? That's how you find the perimeter of a shape. Now, when we start diving into perimeters and talking about similarities, okay, if two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So, what they're saying here is, if I add up, if the two shapes are similar, and I add up all the sides of the first shape over the sides of the second shape, it's going to be equal to one side over its corresponding sides. For example, let's say I said that the perimeter of this shape is X, the perimeter of this shape is 20, and we'll use KL and PQ, and I'll say this has a distance of 5, and that has a distance of 10. Okay. Now, what we can say here, and you'll notice as you look at this, we use the scale factor here. If I use this, I know they're similar, so I know the sides corresponding are proportional. So in this case, I would have 5 over 10, which would be 1/2. This is my scale factor for this situation. Okay. Now, what I can do is I can take my scale factor and set it equal to the ratio of the perimeters. So I could take 1/2 and set it equal to X, since I went small, over the perimeter of 20 over the big. And I would cross multiply and divide, and you would notice that when I cross multiply and divide, I would get X equals 10. So then the ratio of the perimeters would be 10 over 20, which is still also 1/2. So the ratio of the perimeters is going to be the same as the scale factor if your two shapes are similar. Okay? Now, let's take a look here at an example. It says, find the perimeter of similar figures. A larger cement court is being poured for a basketball hoop in place of a smaller one. The court will be 20 feet wide and 25 feet long. The old court was similar in shape, but only 16 feet wide. Find the scale factor of the new court to the old court, and then find the perimeters of the new court and the old court. Okay, so first of all, what I want to do here is I want to draw myself a picture. So I've got we'll make that the new court, and we'll make this one the old court. On the new court, it was 20 feet wide by 25 feet long. The old court, similar in shape, is only 16 feet wide. Well, in order for me to figure out the perimeter, I need to know that value right there. Okay, I need to know that. I don't know the length or the width, or sorry, the length. So, if I look at the shape, the shape of the new court, I can figure out the perimeter because I know this is a rectangle, that this is going to be 20 and that's 25. So the perimeter, if I add all four of those up, the perimeter of the new court is going to be 25 and 25 is 50, 20 and 20 is 40, 50 and 40 is 90. We know the perimeter of the new court is 90. Now, I can still figure out the scale factor. Again, it says, what is the scale factor of the new to the old? So I want new to be first. So the scale factor, okay, on the scale factor here, I'm going to take the sides that I know. I've got these two sides, 20 and 16 are corresponding. So I'm going to write them as a fraction here. 20, again, I want new on the top, old on the bottom, even though I know it's large over small. And when I reduce that, my scale factor here is going to be 5 to 4, 5/4. That's going to be my scale factor. Now, remember what I said about scale factors. The scale factor and the ratios of the perimeter are going to be equal to each other. So, I know the scale factor is 5/4. I know that I have the perimeter of the new court at 90. But I don't know what the measurement of the perimeter of the old court is. Okay, so I really don't even need to find this x value. Okay, that's the luxury of knowing understanding that the perimeter, the ratio of the perimeters, is the same as the scale factor. So now I can cross multiply, and I end up with 5y equals 360 . And now to solve for y, if I divide by 5, y is going to be 72. This is the perimeter of the old court, 72 feet. Okay, so we've got the scale factor right here of 5/4. Perimeter of the new court, perimeter of the old court. Okay, remember the ratio of the perimeters is the same as the scale factor, so they're equal to each other. Okay, let's take a look at this one now. Again, I'm going to do this the same type of way. So I look here, it says here that PQR is similar to WXY. Alright, so I know that they're similar, so I know I can find a scale factor. Well, I've got two sides here that are in the same position, 40 and 72. So I'm going to say 40 over 72. That's going to be my scale factor. If I reduce that, my scale factor is 5/9. That's my scale factor. Okay, so again, my scale factor, 5/9, is going to be equal to my ratio of my perimeters. Now, can I figure out the ratio of the small shape? Or sorry, the perimeter of the small shape? No, I can't. I only know one side. So I've got small on top. I'm going to make that my x. I don't know the perimeter of the small shape. I do know, though, the perimeter of the large shape. Where if I take the perimeter of the large shape, I'm going to take and I'm going to add these three numbers together. 72, 63, and 81. And when I add those together, I get 216. So the perimeter of this shape right here is 216. That's the perimeter. Again, the distance around the outside. Add up all the sides. Now that I've got my scale factor and my perimeter, I can cross multiply and figure this out. So I've got 9x is going to equal 216 times 5 is 1,080. And if I divide that by 9, you end up with an answer of 120. So again, this number right here is the perimeter of triangle WXY. Okay, so again, the perimeter ratio of the perimeters is equal to the scale factor. Okay, the rest of the notes you can just go ahead and cross out. We're not going to talk about altitudes, lengths of altitudes and medians and all those types of things right now. That's not going to be part of what we're talking about. So this concludes section 7.2, part 2. Don't forget to complete your WSQ.